Hello everyone, welcome again. So today we will demonstrate another part of the virtual makeup project where today we will focus on applying a lens color or changing the lens color of the model. Again, this project is a part of a online course regarding the OpenCV learning, which is being presented by Satya Mallick. It's a really good course. I really recommend it if you want to start to learn OpenCV. Plus, the very good tutorials and very nice explanation from the Murtaza on his channel on YouTube. I'll also link his channel in the description with the Satya Mallick course. Okay, so today, as we said, we will focus on the lens color, and this is our model today. So we will focus on changing the eye color after we detect the face and all the face details. Okay, so let's start it. So again, I will use PyCharm to develop the code. So first of all, I will make a new Python file and I will name this as lens color. Okay, there we go. So again, first of all, we need to add our libraries, import the required libraries. So the first library we need today is the OpenCV library, which is CV2. So we have to import it, import CV2. Okay, so with this library, first we have to load our image. Let's say our image equal to CV2. CV2 is the function which is used to load the image into our code, load the image as a matrix. So cv2.imread or image read, then the path to the image, and the path, since the image already added to the same folder of our code, so we just need to type in the name. There it is, dd.jpg. Okay, let's add some comment here. Load the image. Sorry, image. Okay, what else? Let's display the image and see how it looks like in our code. It's always actually to do a lot of testing while developing your code rather than you do all the code one shot then you test it once. It's very hard to debug that time. It's very nice practice to keep developing the code slowly and keep testing always. Okay, so to display the, let's add here comment. Sorry, display the image. Display the image, we use a cv2 function again, cv2.iamShow. This function takes two arguments. The first one is the title of the window. Let's say my original image. The second one is the image itself. Okay, so let's run the code. Run. Again, same thing happened, same as last week. So again, when we run the code, you see here, actually it's run, but because it's run very fast, so it's complete this instruction, display the image, and exit the code. So we have to add a waiting comment. Waiting comment actually is a wait for key to be pressed. cv2.waitKey. That is it. And wait key, this one takes parameter in milliseconds. So if you enter any value, it will be wait for this amount of value. However, if you put 0, it will be wait for infinite. Oops, I guess we have done something here. It's okay. We can do it again. cv2 dot I am sure. I guess I already overwrite it. This one will be original image and img. Okay. So now we should see the picture. Here it is. Okay, so this is our picture model. So now we will focus on changing the lens color. Okay, let's see what we can do. Again, we will use the Dlib library to detect the face. Okay, after we detecting the face, then we go to detect each individual component of the face. For example, the nose, eyes, lips, etc. And today we'll focus on the eyes. But again, before we do any further processing, it's very good practice, especially, I always do it, is to convert the image into gray. So here, let's say convert the image to gray. Okay, so it's always to convert the image to gray before we process it. So the gray image equal to, there's a function that's provided by CV2 to convert the color into gray image, which is a CVT convert color. Where is this? Okay, this one, the first argument it takes as highlighted here is the source, which is the original image. Then it takes the second parameter or argument is the code, which is the CV2 dot color. We need to convert the color underscore from BGR to gray. Okay, because why BGR not RGB? BGR because the OpenCV load the image with blue channel first, green and red, rather than red, green and blue like the normal RGB. Okay, so here we already converted to gray. We can display again to see how it looks like, the gray image. So cv2 dot I am sure again. Here we can type, this is our gray image and gray image. Gray image, yeah, gray image. Okay, so now let's run and see how it looks like. Here we go. So we have the original image, then we convert it into gray. So now we can go ahead and process this image to get the face. Okay, so since we have finished the preparation, this is the place where we do image preparation. Okay, so now we will prepare. Let's type here prepare the Dlib to detect and predict the faces. Okay, so before we prepare anything, we need to include the library itself. So we have to type in import Dlib. Okay, so this is the library that it's required to detect the faces. But why is it called not required? I believe we already installed it actually. Oh, sorry, Dlib, not P. Okay, okay. So now the first thing we have to declare is declare the detector. Okay, so we will declare the detector for the dlib. So detector will be equal to dlib.get frontal face detector. Exactly. Okay, so this detector will be used to detect the faces. Okay, and here we will start to detect the faces in the image. Okay, so to detect the faces in the image, we need to declare a variable, let's say faces. So these faces will bestow all the faces that we detected by the detector inside the image, equal to detector. Then we pass the image that we already processed here, which is the gray image. Okay, so now we can print out the faces to see what we have got. So print the detected faces. So print faces. Let's see. But this is where bit key need to be at the end. Okay, let's see how. Okay, everything good. Here we go. So we have only one face here, and here it is. One face is being detected. Okay, good. We have very good started. Okay, so since we detect the face, let's try to what they call to show or to draw a boundary box around this face. So we use first, since because now yes, we for sure we have only one face, but we don't know, maybe another picture got more than one face, so we was expecting more than one boundary box, so we have to loop through the faces that been detected. So for each face in faces, we loop through each face inside the faces. So we will have how many points? We have 4 points, top left and right, bottom right. Okay, actually I already explained in the last week tutorial, but I'll explain again here. So let's assume we have a face. So each face, or whatever face we detect, if you want to draw the boundary box, we need 2 reference points, which is the start and the end point. Okay, so if we want to draw the bounding box, again, as we said, we need 2 points, which is the first, let's say we want to draw this rectangle. Okay, let's say here we have a face. Okay, so let's say here is the face that we want to draw the rectangular around. So first we need to have this point. Let me call it x1, y1, and then we have the last point, which is, let's say, x2, y2. Okay, so now we have these 2 points that require to draw any bounding box, or actually any rectangle overall. Okay, it's here. Here we go. So if you draw any rectangle, actually, even though you use any software, Paint, Word, or etc., it requires the start point, then you drag to the end point, then you click again. So again, here we will have to have these 2 points. These 2 points actually is these 2 points that's been written from the faces. So each face will give me these 4 points that representing x1, y1, x2, y2, which is this one. So this one represents x1, y1, x2, x2, y2. Okay, so now I will loop through each face inside the faces. Then I will declare x1, y1, x2, y2 equal to, so x1 equal to face dot left, and then y1 will be face dot top, x2 will be equal to face dot right, and y2 will be face dot bottom. Okay, so now we declare all the variables that require to draw the rectangle box. Now we will draw the rectangle or the binding box. Draw the binding box. Okay, to draw the, so now we are not process anymore, we are displaying some information. As we done here, we convert the image to gray to do the process, but if we want any output or any result, we will use the original image. Okay, so let's use the image equal to CV2, draw rectangle. Okay, this rectangle need an image to be drawn on. We use the original image as we said. Then it requires point 1, point 2, and point 3. So point 1 will be x1, y1. Then the end point will be x2, y2. Okay, so we have finished the start and the end point. Now it's required to specify the color. The color is a BGR format, not RGB. So let's set as green. So it will be 0 for blue, green 255, and 0 for red. Now it asks us for thickness. Let's go 3. Okay, so now we draw the bounding box. Let's display the bounding box and see how it looks like. So cv2.IamSure face in the image. Face in the image will be the image itself. Let's run. Finger cross. Oh, so we got the image button. Oh, yeah. So this one shouldn't be should be BO. Yes. Okay, let's run again. Here we go. So we see the sequence now. This is the original image, convert to gray. Now from the gray, we detect the binding box. I mean, regarding to the face, then it will display on the picture. Nice. So what next? So after we detect the face, we need to predict or display the landmarks, what we call landmarks. These landmarks will be showing the position or predicting the position of each individual component of the face, which they are the eyes, eyebrow, nose, jawline, and also the lips. So with that, we need to go back, okay, to the dlib preparation, and we need to declare a predictor. So now the detector is just to detect the what we call the face. Now we have to predict the component of the face. So we have to add predictor. So predictor will be equal to predictor. Actually, we need the data file of the predictor. So here I have two data files. I'll talk to you later about them, but now I will use the default one, which is the 68 one. Okay, so dlib dot shape predictor, and shape predictor actually it needs the path to the data file. And again, I put the path on the same folder here. So I will just copy the name, copy path, copy name, and paste here. Okay, exactly. So I copy this, then later I will use this predictor to predict the landmarks of each component of the face. Okay, here I already detect, so now I will predict. So now I will predict the face components. How to predict them? We call it, let's say, landmarks of the face equal to predictor. And again, this predictor, if I want to, let's think again together. If you want to predict face landmarks, first I have to have what? I have the image and I have to face itself. Again, if I want to pass the image with the face, for sure, because this step is a process, is not a display. So I have to use the gray image again. So I will pass the gray image, and also I will pass the face. Okay, I want to find the face inside this gray image and find the landmarks. So now I already detect the landmarks here. Let's go through the landmarks and display each individual one of them. And again, as shown in the name of these landmarks, it will display or predict. Actually, not display, we will display, but it will predict or return 68 points. So from these 68 points, we will display them now. Then we will pick which point we want to use to make our modification. So for n in the range of what? 68. Yeah, for this 68, what we're gonna do, we will take the x and y for each individual mark. Okay, we will take the x and y equal to landmarks dot part of n dot x. Same goes to the y, equal to landmarks dot part of n dot y. Sorry, dot y should be out of the bracket. Okay, so now we took all the xy coordinates for each individual landmark. So now what we can do in this point, actually we can display them by using the circle cv2.draw circle. Okay, in this circle we want the image to draw again. This step is not process, it's just to display a result. So we will display on the original image. Then it need a center. Okay, it need the center of the point or the circle. Again, the center will be same as the xy that we took from the landmarks. So it will be x and y. This is the center. Now it's asked for the radius, make it 2. Color, let's use, I don't know, make it green, and blue 0, green 222, make it any color, 1 2 3, whatever, any color, not issue. The thickness, we will not define any thickness because we make it fill. We don't want a circle, actually I mean a filled circle, so we will use cv2.fill. Here it is. Okay, so after this we will draw. After we finish this, we will try to draw. So cv2.I am sure we will draw a face with landmarks. Okay, so we will display yes image because we put it on the image. So let's see, hopefully everything okay. Here we go. Yes, let's choose another color, add some more red to here. Make it more obvious. No, wrong. Let's add blue also. 222. Make it 0 0. Hopefully it will be more obvious. Yeah, better, much better. Okay, so now again, this is our original image, gray. I take the face, then from the face we detect the landmarks of the face. Okay, so this is the landmarks of the face. Now we will print out the number, because each individual point of these landmarks got a specific number. Let's print it out. So here will be use put text, cv2.put text. So the text we want again on the image itself, and it's text, the text for sure. The n is the number of the what they call the landmarks point. Then we need the origin, xy, again x and y. Then the font we can use any font, actually, not big deal. cv2.font. Okay, plain, no problem. Then what else it takes? After the font scale, let's say 0.8. Color, actually I didn't like the blue, maybe make it, let's say 222. Let's see how it looks like. Just make it more saturated. Okay, after the color, it's need a thickness, let's say 1. Let's see. So 10 whatever. Oh, I always forgot this one, actually, because n is integer and put text, it takes string, so we need to convert to string. Always forgot this. No, should be okay, should be happy. Here we go. Okay, so now I hope it's clear now. So we can see each individual point got its own number. So with this we can specify on which region we want to do our modification. So now, or in this tutorial or in this project, we will focus on the lens, or on the eye lens. But again, this as we can see here, this point, or sorry, this landmarks does not detect the center of the eye. Okay, so you see, got only the surrounding of the eyes of each eye, got only the surrounding point. So there are two solutions to tackle this, because now we want to draw or change the color of the eye lens. So we have to detect the center of the eye. So the first solution coming to my mind is to draw the rectangle box, not same what we used last time in the polyfill, to take only crop only the eye, but we will draw a rectangle. Then from the rectangle we take the cross, okay, the cross sections of the points, of the 4 points of the what they call of the rectangle. Then we draw a circle in the center. Or the second solution is, since we already perform 70 points detector in the course, the course that provided by Satya Mallick, he already taught us how to perform another point which is in the center of the eye, and we train a new lib data file that it will detect these centers. This is what we have here. This is the 70 points. This 70 points actually is the center of the eye. We already trained them in the course. Okay, so if you want to learn more about this, you can check the course. It will teach you how to do this points where you will detect the center of the eye. So I will use this one because I can see it's very fast and more straightforward and easier solution. So I'll use it to take this center, then I will draw a circle, then I will perform the modification of the color. So with this, I just need to take this change from 68 to 70. So now we should able to detect the center of the eye. Nope, we cannot detect the center of the eye. Why this one? Correct. Oh, this one should be up to 70 also. Okay. I guess 70 or 71, because start from 0, I believe is 71. Yeah, no, 70, correct. Okay, so we can see here, now we can detect the center of the eye. So from the center of the eye, then I can draw my circle to detect the lens, or to simulate the lens color. Okay, so now I have two solutions. Either I continue with this with the 70 points, then later I will filter out the points, or I will select the n in the range of 68 to 70. With this, directly I filter out all the other points that I don't need it. So now I will end up only 2 points at the center of each eye. Here it is. Nice. Okay, so I will work on these 2 points and I continue my code. Okay, so these 2 points, first of all, I will collect these 2 points. I will add them into a list. So I will declare a list somewhere here. I will call it landmark points. Okay, this is a list that I will record all the center of the eye coordinates. So here I will append it after I found the xy. So landmarks points dot append. I will append what? X and y. Okay, so I'll append these 2 points xy. 2 points for 2 eyes, it means 4 points. Okay, good. So after I append these 2 points, I should be okay now. So let's go to what else after I append. Let's see. Now I already append the 2 points. What else after I have these 2 points? Yes, I have to find a mask. Then from the mask, I will draw these 2 circles in the white color. Then I will merge them with another background color. Then I merge them together using AND, bitwise AND. Then we continue. Okay. So here we finish with the eye detection. Then let's say here, preparing the mask. So to prepare the mask, we have to find the mask equal. Mask will be for sure exactly the same size as the original image. So it will be np. Here we need to declare the new library import. We need to declare numpy as np because we will use we'll play with the matrices, and npy is very fast to manipulate matrices. So it will be np dot zeros like my original image. Okay. So this is the mask. We can display the mask. cv2 dot. Let's put this there. Let's put this one here. So this one will show us the center of the point, the center of the eyes. And this one, okay, mask. To display the mask. So the CV2 equal to I am sure this is our mask and mask. Let's see. So now we can see the mask should be same size with black color for sure. Mask. Okay, here it is. Okay, so this is the mask, exactly same size as the original image, but in the black color because all zeros. We haven't done any any process on the mask yet. So now I will add on 2 circles, 2 filled circles on the center of each eye. But again, this one, I won't say that this is not the real optimal way or the good way to do. Maybe for sure there's a lot of ways out there online to show the correct way to do it, but this is how I found it easy for me to do. So I will say the left eye mask, or not mask actually, left eye equal to cv2 dot circle. Okay, so I will draw the circle on the mask. Okay, so I'll draw this circle on the mask itself. Then we need the points. These points is a bit tricky. You have to focus a bit with the points. Let me comment this. And here let's print a landmark points. So for sure we'll use this landmarks point. You see these 2 landmarks point now that we already append them in the landmark points. This is the 2. This is the first eye. This is the second eye, or the left and right eye. Okay, so this is the point. So we have to index each one of them individually inside the circle, the eye circles. Okay, so the first one after the mask, open bracket, so will be the landmarks point of 0 of 1. Okay, so of 0, sorry, this one 0 0. So the first one will be 0 0, this one. Then landmarks of 0 1. Okay, so 0 0 0 1, 0 0 0 1. Okay, that's good. What else left? I guess now we should enter the radius. The radius, actually, from my experiment with this image, my model image, the 16 radius, it's fit well. Maybe another image got different radius. Again, I told you this is not the good optimal way to do the virtual makeup of lens color changing. Color of this, for sure, this one, because we are working with a mask, so we will choose a different color since our mask background will be black, so this one will be white. White is mean 255, 255, 255. This is the background color for the eye. Thickness will be filled. CV2 dot fill. Okay. So now I will copy this because it's too long and I'm lazy to type in again. Now we will type in the right eye. Okay. The right eye, same, but here we change to 1. 1, 0, and 1, 1. Okay, 1, 0, 1, 1. And exactly the same. So now we can display the mask here, maybe. So I am sure, sorry, CV2 dot I am sure here will be the mask with eyes will be the mask. Okay, here it is. So here is the mask, and here is the mask with the eyes, that it's matched exactly the eyes of our model. Nice. So now, after we declare this, now we declare the color of the eyes that we want. The color will be RGB or BGR, whatever, but the sequence of the color will be BGR. So B, comma G, comma R equal to, let's say, blue 2, 3. This is just any colors you like. Later we will change a lot to see what is the nice color match with our model. Then I will make another eye color equal to numpy dot zeros. Actually, this one we just copy. Actually, we can just copy the mask, but no problem. Like the mask. After we copy from the mask, then we declare the color, because now the color will be black or same whatever the mask it is. So now we will change the color, eye color, of whichever is the dimension or the size of this equal to BGR. So now if we see it, sorry, CV2 is to see how it looks like, I am show. So from here, let's display the color, eye color. So this is the eye color mask. Actually, not the mask yet, just the eye color. It's not the mask yet. And eye color. Just the color is not mask yet. You see now? Why this color like this? Something wrong? Eye color. Okay, first we're doing the mask. BGR. Yeah, should be okay. Because now weird. Maybe because this one is all actually low values. Let's add 2 here, because I can see it's not really dark. It's a bit like grayish color. Yes, here it is. You see now? It's green now. So now, yeah. So now what we can do, we can find the eye color, or the colored eye color mask. So eye color mask will be equal to CV2 dot bitwise n with the mask. Okay, the mask with the color we do just now, which is the eye color. So from here we can display again or show the mask image again, cv2.IamShow. This is the color eye mask, which is the eye mask. Let's see now. So now we can see exactly the same like the mask, but only the white region will be in the color we choose. Here it is. Okay. So here we just match these two now with endwise. We got, so bitwise n. So we got this one. So now we have to merge this one with the original image. Okay. But before that, I believe we need to add some blur, because now if we can see, the edges of the circle of the eye is too sharp. When we just merge them like this, it will be very obvious and not nice. So we add some blurring. So we say eye color mask is equal to cv2.Gaussian blur. Gaussian blur, it's need a source image. For sure we use the same one, the eye mask, because we are blurring the mask itself. Then it's need the kernel. Let's use the same like last week, 7x7 plus segment x second. Okay, so now we blur it already. Let's again, we see how it looks like. cv2.IamShow blurred colored eye mask, eye color. Now we should see the same mask image, but now it should be blurred. Here it is. See now? This is very sharp edge. This is blurred edge. Now, this is the end and the fun part. We just have to marry this, the last image, with the original image. So we say final image is equal to cv2.add weight. Sorry, add weighted. So this add weighted, it takes the source, which is the original image or the image. This is the source one. Okay. Then we will see how much we want to keep of this. For sure, full will be 1. And the second image is the eye mask, eye colored mask. And the percentage of this is around 0.4. And the gamma 0. Okay, we're now almost finished. So we need to display cv2. Sorry, this one here should be here. cv2.IamShow. This is our final, and is the final image. Okay, finger crossed. Let's see now. We should see the final image or the original image with the colored eye. Here we go. But now again, let's do something, because now we see the original image. Actually, throughout our code we keep adding, so it will take the overlays a lot from this one here. So let's make a copy from our image. Here's then the Ori image. Make copy Ori image. So copy Ori, let's say finer or not equal just Ori equal to image.copy. Okay, so we call it Ori, so this one will be add weight with the Ori. Okay, so with now we can see only the original one with the new eyes. Here we go. So again, you can see actually here it's quite nice. I like the result and I like the output, but we can do better maybe in the future to, I don't know how to nicely marry these two colors with the eye, because if you can see, not all the center of the eye is appeared. Some of them it's hidden. However, it's okay. I'm like the result. So we can see here, this is the original one. We convert to gray. From gray we find the binding box. Then we find the center of the eye, mask it. Okay, then from the mask we find the two eyes center. We calculate the color. From the color, then we find where is the other one. From the color we find we merge the color with the marks to get these two eyes only. Then we blur them. Then we merge them with the output. Okay, so now let's try to change the color. Say from this mode to green, make it more blue, and reduce this. And again, now should be bluish. Here we go. Nice. I like the output. I like the results. Should be okay. Yes, very nice. Okay guys, so thank you very much for this. Let's see our sequence. We start from where? We start from here. Again, original, convert to gray. We find the binding box. From the binding box we calculate the, where is it gone? We find the two center of the eye, which is the landmark. Then we find the mask, okay, the black mask. Then the the color of the eye. Then find the center of the mask again, center of the eyes again. Then we merge them. So with this, we have reached the last part of this project and tutorial. So thank you very much, and I hope you have learned something from this. And let me know if you have any comments or questions. Thank you very much, and see you soon.